Hello, and welcome to the World of Threats by Eric and Saeed. The what and how. This is a diagram explaining what threads are and how they appear. What we're going to talk about are threads. How threads are found in all processes, and each process have at least one thread. What exactly does this mean? Basically, threads consist of four major things. Those are the program itself, the counter, the register set, and a stack. Each are basically there to share information between each process that are within the same process to complete a task. This depiction shows a better understanding of what's kind of going on as a thread is being processed. There are two types of threads when dealing with either a user level thread or a kernel level thread, each having their advantages and disadvantages. User level threads are easily implemented and are recognized by the OS, while the kernel is only implemented by the OS and recognized by the OS. As stated earlier, it's much easier to implement as it's not needed to be recognized by the OS for you to implement, as where recognition from the OS is needed on the kernel side. It does allow for faster context switching and no need for hardware support on the user level, as this is done through the user. On the other hand, where the kernel still needs hardware support in order to have context switching. The biggest advantage between user and kernel is that if there's a blockage in operation for the process of the thread, the whole entire process is either blocked or then terminated. As on the other hand, the kernel, another thread will form and continue to execute. What does this all mean and how is it used? Since threads are a lightweight process, this is the main goal and perfect for achieving multitasking by dividing a process into multiple threads. There are three forms of threads, but we'll get to that later. This is a great example of showing how a multi-thread could exist within a process. And as you can see, we're going to open up Word to kind of simplify the idea of what a thread is. As you can see, I'm within a program right now, and I'm going to select a new blank document. While being within that same program, I'm able to type, as well as see that it's proofreading as I type, making sure that I do spell correctly, as well as checks for grammatic errors, and the software itself saves. Those are many forms of what multi-threading occurs. As you can also see, if I were to open a new window, I can go switch from any tab to a new tab to opening up a new tab, and the list goes on. These are all simple forms of tabbing through, as well as any form of multi-threading or tasking that threads provide.
There's three forms of multi-threading. Many to one is the first. Many users level threads to one kernel level thread. This allows the application to create any number of threads that can execute at the same time. Also, only one thread can access the kernel at a time. A second option is many to many. Many user level threads to many kernel level threads. It avoids many of the limitations while extending multi-threading capabilities even further. This model is also called the level model. It minimizes programming effort while reducing the cost and weight of each thread. And the last option is one-to-one, one user level thread to one kernel level thread. In this option, each user level thread created by the application is known to the kernel, and all threads can access the kernel at the same time. Here are a few advantages of multi-threading. It is more responsive, it has faster context switch, it has effective utilization of a multi-process system, it has resource sharing, has better communication, and has enhanced throughput of the system.
All making multi-threading the main focus of what a thread is. We'd like to thank you for your time, and we hope you learned something new.